Good morning, students. Today we are going to see about noise figure and noise factor. So very important to know question in everything: noise figure and noise factor. So in general, the noise factor is nothing but signal to noise ratio at input to the signal to noise ratio at the output. So this is called as a noise factor. Noise factor. Both the letter we are representing F only, so it may lead to confusion. So it is nothing but noise factor will be signal to noise ratio at the input to the signal to noise ratio at the output. Okay. Then if the same factor, if I represented in terms of decibel, if noise factor is represented, then it is called as a noise figure. So 10 log of noise figure in terms of decibel is nothing but 10 log of base 10, it is F. So this F is nothing but noise factor, and this F, whenever F is represented in terms of decibel, it is called as a noise figure. Okay, the remaining everything will be the same. Then a noise temperature. The noise temperature formula is F minus 1 KTB. The noise temperature formula is F minus 1 KTB, where B is the Boltzmann constant, T is the temperature in Kelvin, and K is the B is the bandwidth, T is the temperature in terms of Kelvin, and K is the Boltzmann constant. Then F is nothing but the noise factor. So this is the noise temperature and noise equivalent temperature, which leads to then this will be compressed into the formula called F minus 1 into T naught. So this is your noise equivalent temperature, F minus 1 into T naught. So T naught is the room temperature. Okay, so noise temperature is defined as a temperature at which noisy resistor has to be maintained, so that by connecting this resistor to the input of noiseless version of the system. So it is called as a noise temperature. Thank you, students.